Time to get into this Bogner Metropolis. And you'll notice that we've got a Vactrol or thermal limiter, I'm not sure which, right here. That gets hot. This component here is a voltage regulator. It gets really hot. Notice the big heat sink. And you've got a 5-watt resistor here. That can also get hot. And what do we have right next to it all? This capacitor, rated for 85 degrees, I'm pretty sure. And while it is not visibly failing the way these other two were, where they had the leakage spewing out the end, I would not be surprised if that capacitor has had a really hard life. And I will think twice before I put the new capacitor there. 500 volts, 22 microfarad, 85 degrees. Now, granted, 85 degrees is Celsius, so it's quite a bit of heat, but that's just a lot to expect out of any capacitor. If I had to have a capacitor there, I would choose a 125 degree, but better not to have the capacitor there. And it's also good with PCBs to realize when a radial is a better choice. An axial there is exposing a lot of it to that. They could have done the board layout differently, had a radial right here, etc., etc. They've done radials other places, so they are familiar with the concept. But this is a terrible place for a capacitor to be. I'm changing out the cathode bypass capacitor at the same time as the others. Clinch on the other side. There it goes. High-tech solution. All right, let me get in there with the soldering iron, get these old leads out, and get the solder joints ready for the new caps. Well, Shaznut. I was hoping to be able to pull these leads out, but they are crimped on the other side of the board, which is good, except that to get those cap leads out, I've got to pull this board to access the bottom. And that would be fine, except that they have all this hand-wired stuff here connected to the front panel. So I've got to take everything off the front panel to pull this board. And I've got all this nonsense here. I got to make sure I don't strain any solder joints or et cetera, et cetera. It's a whole lot of labor that would not be necessary had this amp been designed to be serviced. Great example of making it cheap to build, but expensive for the owner to own in the long run. All right, here are those negative leads that would not come up from the top side on these caps. And I thought they were just crimped over on the bottom, but no, Bogner had to go insane. They've got them all going to this bus wire, which does make for a solid ground. There is a ground trace up here, a fairly thick one. This is not really necessary. It certainly makes the amp more difficult to service. And here's the ground connection that goes to chassis. This is HT center trap ground, et cetera, et cetera. So the fix for this, first of all, is just to snip this bus wire out so I can get all the individual leads out. And I'm not cutting where the wires are connected yet, because there are holes in the PCB on this ground trace where this wire can go. It was designed to go. I don't know why they did this bus here. Maybe they decided that it was not adequate to have this pretty good sized trace up top. So once I get all these things soldered in place where they're supposed to be, I think I'll do a bus reinforcement top side along all these so that it will have more metal there. It'll be an improved ground, which is what they seem to be going for. but it'll be top side, so the next tech won't have to pull the board to do it. Okay, got all the old solder out where the caps are going to go. The other cap's not visible in the shot as well. But before I put the new caps in, I want to get all that old flux off. I know. Seems OCD, but flux itself can become conductive, and flux traps dirt, and I don't want any contaminants from this old flux down in my new solder joints for the new filter caps. Doesn't take very long to do. It's easy to do, and it can make a difference. Doesn't always. Won't know until you don't have a problem you might have had before. So it's just kind of a best practice thing. Whenever working on a PCB especially, I like to get it to much as new as possible condition. I do both sides. So I will have a nice clean spot. And all that gunk on there is old flux. It does look like Keith Richards' lungs, but it's flux. Okay. So now it's time to put caps back. I'm going to start with the 330 microfarads. All right, just as you've seen me do on Fender reissues, got the new leads installed and crimped over and snipped before I cut. It means I have to heat up less metal so the solder will flow better, and I won't have any mechanical shock introduced to the solder joint if I were to snip the metal before it's fully set. And each lead gives some mechanical support to the capacitor. So it's not just using the solder as glue. The cap really wants to stay there before solder is applied. And I've got a little bit of silicone between the body of the capacitor and the board. So once that silicone sets up, between that and the mechanical support these little crimp hooks give, they won't be going anywhere. So that gets us to this point. Got three new 30 microfarad. You can see a little bit of the silicone down there. And those will set up really well and be very strong. All the values are visible. I do the 222s across those in a little bit. I'll do the bias cap first. Let's see. Just confirming. Yeah, it says positive on the board, but I like to confirm. That's the positive end. And this is not the Vichy I would normally use, or the et cetera, but for the value necessary, I was trying to keep the cost down for this owner, and with shipping costs these days, it made sense to get everything from one vendor, so I didn't order another $2 or $3 capacitor with $10 shipping for this amp. I spend so much of my time straightening out the leads on these axles as they are shipped to us. Doesn't really matter, except that it bothers me. I like to have things as neat and as close to straight as possible. Now, they've got this place in the board here for a zip tie to go through and help bear the weight of the cap. I don't think that's really necessary. It's not a very high mass cap, and I will use some more silicone. But I do want to get some physical distance between it and that 10-watt resistor. So I'm going to get the value up and just kind of eyeball it. All right, right about there. That'll be good. So again, I'm going to lift the board up, crimp it in place, solder that, then I'll give it a dab of silicone instead of the zip tie. Zip tie is not necessary in this case, in my opinion. And now we've got all the caps back in place. I decided to put this cap here after all. I was going to see if I could mount it over here, just run a wire to this positive, but there wasn't any real good way to mount it over here without doing something kind of sloppily engineered. And I considered mounting it to a standoff or something, maybe using one of these screw holes that you can't see, one of these unused screw holes, maybe doing a standoff. But I decided it's a $3 cap. It's pretty easy to remove top side and replace in the future. And I just moved this component away from it, and I bent the fins of this massive heat sink away from this cap and away from this cap. Won't affect the performance of this heat sink. It's still big bits of metal up in whatever air flow there is inside the chassis, but it gets it just a little bit farther from these caps. That helps. Since Bogner had that bus wire on the bottom, I put a bus wire up top reinforcing this path. The HT center tap is now going here, and the ground to chassis is here, and this is all good. And a cathode bypass cap for the output is in place, and it's got a little bit of silicone as well. Time to put all this stuff back in place and see what it begins to sound like. All right, putting everything back together, and before I power it up, the JJ EEL 84s that came with, see how pale the labeling is? That would have been a bright red when it was new. These tubes have been baked. In the trash they go. And, all right, I brought it up on a light bulb limiter, confirmed that the missing F3 is not keeping it from working. We've got B+, we've got heaters, the rectifier is working. I turned off the light bulb limiter, and I had measured the bias resistor. It says it's 150 ohms. It's 150.1 ohms. And I've got a pair of Chinese EEL 84s in there for a test right now. So with 120 volts coming out of the wall, across that cathode we have 14.3. And plate to cathode we have 340. And that will tell me that we have total current through that says we got 16.2 watts per tube. Some of that is going to be through this, about 5% is going to be through the screen grid resistor, which leaves us with 15.39 watts per tube. Bogner is one of those companies that doesn't read data sheets. A EEL 84 is nominally a 12 watt tube. Some of the 7189 variants are 14 watt tubes. And in a cathode bias amp such as this, which is borrowing an awful lot from a AC15 as to its general premise, you want it to pretty much be between 12 and 14 watts idle, but not at 15.39, even taking into account the screen current. So this 150 ohm 10 watt resistor has got to go. We need to go up, and I bet 200 to 250 will do us right. So let me pause here, change that out, and see where we end up. All right, I've temped in a 200 ohm. If this ends up being the value that we need, I'll do a neater job. But for right now, we get a 200 ohm resistor, which measures 199.3 ohms in actuality. And we have 15.5 volts across it, which is up from the 14.3 before. And our new plate to cathode voltage is 348.7. That has gone up 8 volts. And now total current would equate to 13.56 watts, but 5% of that is current through the screen. So the plate current is estimated to be 12.88 watts, which is ideal. So I'll neaten up the install of this resistor in a little bit. Let's see how the amp is sounding, make sure there's no other issues. Don't need to get any other tubes, etc., other than the EL84s. And the fact that it was idling at 15.4 watts with 120 volts coming out of the wall is why those JJs died. And for those who think, well, what is this guy doing, making changes? Bogner's famous and they know what they're doing better than some guy in Memphis. You'd think so. I wish that were the case. Anyway, let's plug a guitar in and see what it's sounding like. All right, I got a Strat plugged in, neck middle for the start. No noise on the pots. Presence is working. Kind of hard to turn the pots without the knobs. But I'm not going to put the knobs back on until I'm sure everything else is done. It doesn't have to come back out of the chassis. Well, let me tell a lie. Let me put one on for the rotary position, whatever it is called. They call it the schizo knob. I'll just temp a knob on there real fast so I can turn it, because there's no way to turn it by hand easily. So let's see what that does. So 1, 2, 3, 5 position switch. All right, so I'll put it to position 3. And then I'll put the knob on with that being new. Sounds pretty healthy. I think it'll work. You know, I just did a full cap install, so it needs to have a good bit of burn in. And one last thing about this design makes me a little uneasy, but it's the way it was when it came in. There's not much clearance between these caps and the top of the chassis, so let's make sure that it's kind of clear. By a fraction of a millimeter it clears. Good. So I'm going to clean up the install of that new output cathode bias resistor, and then I'll put the knobs on and put it back in the cabinet and make sure the speaker it came with is good. We'll get some new EL84s. It's cathode bias, so I won't have to do anything to bias it. I've already done the biasing, and that should work with pretty much any good pair of functional in-spec matched EL84s.